3.2a. Okay, so draw pictures like this where you have from A to B, and this is decreasing. From A to B, and this is increasing. Okay, what do we know about the derivative at this point, f prime of x? Is it greater than 0, less than 0, or equal to 0? You're right, it's going to be less than 0 because the slope would be negative. So we can state over here that f is decreasing on the interval AB. Okay, next one. Right here, f prime of x is greater than 0. So f is increasing on the interval AB. All right, we have a theorem, and it states if f double prime x is greater than 0 on interval AB, then f concaves up. I almost drew a little U. Okay, so it concaves up. If f double prime x is less than 0 on AB, then f concaves down. So it'll look like that. Okay, we're going to draw now a picture that shows increasing, decreasing, and concavity both ways, up and down. Okay, so just draw this. We're going to make a little table here. All right, so let's draw this picture. All right, we know f prime of x for some point here is going to be greater than 0. Now, is this particular line, is it concaving up or down? You can think of concaving down as like spilling water. Concaving up, you can think of it like this, holding water, right? Concaves down, the water would fall out. Okay, so does this look like it concaves up or down? Correct, it concaves down. Now, let's ask this. Is this increasing or decreasing? Is f increasing or decreasing? F is increasing. Okay, let's draw this picture. Is f prime of x greater than 0 here? Yes, it is as well. Okay, it concaves up. It also is increasing. Okay, so now let's go this way. Here we can see f prime of x is less than 0. We can also see that it concaves down. Is this increasing or decreasing? So moving from left to right, we can see that y is getting smaller and smaller and smaller, so this is decreasing. All right, the last one. Okay, f prime of x, still less than 0, right? It's still going this way, which is decreasing. This concaves up. And it is also decreasing, because as we move from left to right, y gets smaller and smaller. Okay, what else can we put in this now that we looked at our new theorem? Well, for concaves down, for these two, we can also state that f double prime x is less than 0. F double prime x is less than 0 because it concaves down. And because these concave up, we can state that f double prime x is greater than 0. F double prime x is greater than 0. Okay, we're going to look at another picture. If we have something like this, where it switches from concaves down to concaves up, we call this the inflection point. Inflection point. All right, we have a theorem where it states this happens where f double prime x equals 0 or where f double prime x does not exist.